Okay, so we're going to do the problem that was on your midterm. So calculate the area of the ellipse x squared over a squared plus y squared over b squared equals 1, and show that that area is pi times a times b. So as you can see from Folk's picture, the ellipse is symmetric about the x and y axis. So to calculate the area of the entire ellipse, we can just calculate the area of the portion that's in the first quadrant. Okay, but the area of the portion that's in the first quadrant is the area that lies below this curve right here. So first step, let's calculate what the equation of that curve is. So I'm going to solve this equation for the ellipse for y. Apparently I break the chalk too. Y squared over b squared equals 1 minus x squared over a squared. Okay, and now I want to solve for y, so y squared equals b squared times 1 minus x squared over a squared. So I take the square root, and since I can see that y is positive here, I get y is the positive square root of b squared times 1 minus x squared over a squared. So how do I calculate the area under a curve? Well, we just use an integral, right? So the area in the first quadrant, so I don't know. The area will be 4 times the area in the first quadrant, so I'll put a 4 there, which will be the integral of this equation here, so square root of b squared times 1 minus x squared over a squared dx. And now we need to find the limits of integration for x. So x is going to start at 0 and is going to go all the way to a. Like that. And now I just want to simplify this a little bit before I go any further. So I can bring this b squared out. And in fact I can bring over a squared out. Something like that. And when you get this far, you should be thinking trig substitution, because this looks like the hypotenuse, or this looks like something that appears in Pythagoras' theorem, right? So we have a triangle, we have an angle theta. If I want this, if I think of this as being something that appears in Pythagoras' theorem, this is going to be one of the sides, where a is going to be the hypotenuse, maybe x is that side there, and this is going to be a squared minus x squared. Okay, so what's the substitution that I make? Well, how can I relate theta and x in an obvious way? Well, let's try sine theta. So sine theta is going to be opposite over hypotenuse, just for a. You could also choose cosine theta, so you could also draw x to be here and the square root of a squared minus x squared to be on this side and use cosine theta, but I'm not going to. I'm going to use sine theta. Okay, so if sine theta is x over a, so cosine theta d theta is 1 over a dx, and this is the substitution that we make. Okay, so this whole thing is going to be, so the 1 over a dx is going to turn into cosine theta d theta, but we need to figure out what that cosine theta is in terms of x, so we know how to change this, right? So if you look, cosine theta equals the square root of a squared minus x squared adjacent over a. Okay, so maybe let's just write this. So d theta is going to be 1 over cosine theta like that. Okay. Okay, so I don't have 1 over the square root of a squared minus x squared, so let's maybe just rewrite this. Like that. Now, dx over the square root of a squared minus x squared, that's going to be d theta, and then we have to change the other part into thetas. Okay, so a squared minus x squared, that'll be a squared cos squared theta. And then dx over square root of a squared minus x squared is just d theta. Okay, but what are the limits of integration now? Well, we have to go back to our substitution. So if x starts at 0, this side is starting at 0, which means this angle here is going to start at 0. You could also see that just by solving this equation. If x is going to go all the way to a, the hypotenuse and this side are going to be the same, which means that, in fact, you're not going to have a triangle, you're just going to have a straight line, and so the angle is going to have to go all the way to pi over 2. You can also see that by solving this equation, because you'd have sine theta equals 1, so theta should be pi over 2. Okay, so now we're going to calculate. So that's going to be 4 times a times b times integral from 0 to pi over 2 of cos squared theta. At this point, we want to use our half angle, or double angle, or whatever you want to call it, identity. So cos squared theta is a half plus 1/2 cosine of twice theta. And now this is something that we know how to integrate. So we get 4 times a times b, theta over 2, plus 1/4 sine 2 theta, all evaluated from 0 to pi over 2. So if I plug in pi over 2, here I'm going to get pi over 4. So I'll get 4 times a times b times pi over 4. Here I'll get sine of pi, which is 0. If I plug in 0, I'll get 0 there, and sine of 0, which is also 0. So I could just get 4 times a times b times pi over 4, which is just pi times a times